Hey, welcome back. So, when you're starting with machine learning, one of the biggest challenges is choosing the right algorithm. There's so many options like classification, regression, decision trees, neural networks, and etc. But how do you know which one is the best for your problem? In this video, I'll walk you through my exact thought process for selecting the right ML model when I was creating my Django with machine learning course, where I had to build a model for predicting the stock price movements. I'll start from absolute basics. What is machine learning? The different types of machine learning and how to decide which one fits your use case. Then I'll also show you why I moved from traditional machine learning to deep learning. And finally, why I ended up choosing the neural networks LSTM architecture for predicting the stock price movements. So if you're feeling overwhelmed by all these different types of algorithms and struggling to figure out which one to use for what kind of problem, this is the right video for you. I know it's a bit of a long video, around 30 minutes, but you know what? This topic itself is overwhelming. And to really master it, you have to spend a little extra time because you see, anything that's too easy has no real value. This one is a bit tricky, and that's exactly why not everyone understands it. But by the end of this video, you will have complete clarity on how to choose the right machine learning algorithm for your problem. Let's jump right in. First off, what is machine learning? Well, machine learning is a process in the field of artificial intelligence where computers learn from data and make decisions or predictions on their own. It's like teaching a computer to recognize the patterns and make decisions based on those patterns. We've been experiencing machine learning every day, knowingly or unknowingly. For example, the spam detection in your Gmail account. It uses machine learning techniques to decide which emails are spam and which are not spam. Similarly, the YouTube video recommendation system. Again, it uses machine learning techniques to recommend you the videos you likely want to watch. So many other things like self-driving cars, voice assistants like Siri or Alexa, Amazon product recommendation, movie recommendation in Netflix, and you name it, they all uses machine learning and artificial intelligence in their system. There are mainly three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. What is supervised learning? Supervised learning is a type of machine learning where a computer is trained using a data set that includes both the input data and the correct output. It's like teaching a computer by examples. Imagine you're teaching a kid to identify different animals. You'd show him a cat and say, "This is a cat." And then you also show him a dog and say, "Hey, this is a dog." You're giving this kid labeled examples to learn from. Tomorrow, you bring a new cat and ask this kid, "What is this?" He'll probably say it's a cat because you showed him a cat yesterday and told him it's a cat. He remembers it. He learned from the label you said, "That's cat." That's exactly how supervised learning works. We give the computer a bunch of data points with labels. The algorithm, which is like a computer's brain, analyzes these examples and learns the patterns that connecting the data to the labels. Once it's learned enough, we can give it a new or unlabeled data and it can predict the correct label. Okay, just like how this kid identify it's a cat. So there are mainly two types of supervised learning: classification and regression. Before I explain about classification and regression, let's quickly have a look at what are unsupervised learning and reinforcement learning. Well, unsupervised learning is kind of like the opposite. It's a type of machine learning where a computer is trained on unlabeled data. The goal is to identify the patterns or structures within the data without any labels. So let's take an example. Imagine you are giving a kid a bunch of different animal toys, but this time you don't tell the kid the name of any of the animals. Instead, you just let them play and group the toys however they like. So even without knowing the names of the animals, the kid will likely start grouping similar toy animals together. They might group all the toy cats, toy dogs, and toy tigers based on the features like fur, tail shape, facial structure, eyes, and even the colors. The kid is actually figuring out the patterns and similarities on their own without needing any labels or instructions. So that's basically what supervised learning does. We give the computer a bunch of data, but we don't tell it what's what. The computer looks for the patterns and groups things together based on their characteristics or the features. So this kind of learning is really helpful in the real world. For example, businesses can use the unsupervised learning to understand different types of customers, and banks can use it to find the patterns in the transaction that might be fraud. And even movie streaming services also use it to recommend the stuff you might like. So that's about the overview of unsupervised learning. What is reinforcement learning? Reinforcement learning is a type of machine learning where a computer learns to make better decisions by receiving rewards or penalties for its actions. Let's understand this better using an example. Imagine a kid is learning to walk. At first, they might crawl or stumble, right? But eventually, they'll start taking a few wobbly steps. Every time he take a step in the right direction, you clap or you cheer, right? Which is a positive reinforcement. You see, here the reinforcement means the process of encouraging particular behavior through rewards or feedback. Now, if the child falls, he'll feel a little pain, right? So you might gently help him up to stand up again, or you offer a hug and say, "It's okay, try again." So this teaches them that falling is not fun. So they will try to avoid doing things that might cause them to fall again. So it's like a reminder to be more careful next time. So it's basically like if the child walks correctly, you clap and cheer, which makes him think that he's doing something good or something right. But when he fall, it's kind of a signal that this particular action wasn't quite right. So over time, with lots of practice and constant feedback, both positive and negative reinforcement, the child will gradually learns to walk more confidently. So he'll understand which movements are successful and which ones are a failure, all without needing explicit instructions on how to walk. So in reinforcement learning, the computer tries different strategies to solve the problem or to reach the goal. And for each actions, it gets feedback in the form of a reward or a penalty. So if the strategy brings it closer to the goal, it gets a reward. And if it fails, it gets a penalty. So with enough practice and feedback, the computer learns which actions are more likely to lead to success and gradually gets better at the task. Okay, so that's how the reinforcement learning work. The best example for reinforcement learning is, self-driving cars. So self-driving cars use reinforcement learning algorithm to drive in real-world traffic conditions. So they receive rewards for safe actions like, maintaining the proper distance between the vehicles and for following the traffic signals, etc. They also get penalties for unsafe actions, like sudden braking, speeding, or causing accidents. So with this constant feedbacks, the AI driver will gradually improve its decision-making ability. And over time, it will become more skilled at driving in the real-world conditions. So that's one of the best examples for the reinforcement learning. So far, we have learned what is machine learning and the different types of machine learning. I want to show you a clear picture of how does this whole machine learning landscape look like. So in machine learning, we have supervised learning, unsupervised learning, and reinforcement learning. Now in each of these categories, there are many subtypes and algorithms. Okay, for example, in supervised learning, we have classification and regression. Similarly, in unsupervised learning, we have clustering, dimensionality reduction, and associate rule mining. And in reinforcement learning, we have model-based methods and model-free methods. And again, in classification, we have logistic regression, decision trees, random forest, and gradient boosting, and all that. And then regression, it has linear regression, polynomial regression, and so many other things, okay, including neural network for regression. So the same list goes with unsupervised learning also. It has, it has clustering. In the clustering, we have k-means clustering, hierarchical clustering, and DB scan and other things. Okay, so the machine learning is a very huge topic. So what I'll do is I'll actually provide you the resource where you can see the whole machine learning landscape. So you can download it from the resource section of this lecture. Anyway, since this course is not a complete machine learning bootcamp, It is specifically focusing on the supervised learning, where we can use neural networks LSTM architecture to predict the future stock prices. So that's why this course will not cover unsupervised learning and reinforcement learning in detail. Okay, so because we are working on a specific use case where we need to use machine learning algorithms to predict the stock prices. As you can see, in supervised learning, there are mainly two types of problems: classification and regression. Let's dive a little bit deeper into supervised learning to figure out which category our stock prediction problem falls into. Well, classification is a type of supervised learning where the goal is to predict a label or the category based on the input data. Just like teaching a child how to identify different animals with the labeled examples, right? So in classification, we train a model using the labeled data. For example, the photos labeled as cat or dog. So after learning from a lot of labeled examples, when the model is given a new or the unlabeled data, it can actually identify it or classify it based on what it has learned from the previous examples during the training. Let's take another example of how spam filters works in your email client. It uses classification to decide if an incoming email is a spam or not, based on the patterns it learned from previously marked emails by other people. So it actually learns from the data points and the features. So each email is a data point, and the feature could be the words in the email and the grammatical errors or the sender information. So the goal here is to give a label to the email as either spam or not. The algorithm learns which features are typically associated with the spam emails, right? So maybe you might have seen a lot of spam emails, right? So it sometimes contains, free money or win a lottery or some, it also comes from some suspicious email address, right? So these are all the spam emails that will be filtered out before it even hits your inbox. So this is actually a classification problem, but it doesn't have anything to do with the predicting the numbers or prices, right? Regression is a type of supervised learning where the goal is to predict a continuous numerical value. Imagine you are trying to guess someone's height. You might look at their age, and you might look at their parents' height, and you might also consider their shoe size, right? So based on these features, you will probably predict a height of a person. You see, you're not putting them into a category like tall or short. If you had to predict whether the person is tall or short, then it would be a classification problem. But in this case, you are trying to pinpoint an actual height, an actual number. So that's what regression does. You have seen the weather app. So it doesn't just tell you whether it's a sunny day or rainy day. It gives you an actual temperature prediction. It's a numerical value in degrees Celsius. So that's regression in action. I hope you understood this. If you want another example, think about the house price prediction application. So here what happens is your model will be able to predict the price of a house based on the features like how many bedrooms it has or what the area of the house and the locality of that house and the price of similar prices sold in the past. So here each house is a data point. And what are the features? Features are nothing but the number of bedrooms, the area of the house, the locality, and the past sold price. So that's a high level overview of how regression works in supervised learning. You might be thinking we can predict the stock prices too using regression algorithms, right? Well, you're absolutely right. After all, our problem statement is to predict the numerical values, which can be solved using regression. But there's a catch. Stock prices are not like house prices. They change constantly and are influenced by numerous factors from the past. The stock market is like a living thing. It reacts to the human emotions. For example, stock prices can rise due to a positive news about a company. Maybe Tesla's stock price go up if there is news about it receiving a huge order. And the prices can fall down based on the negative news about the company. Typically, the stock market follows trends such as uptrends and downtrends. So there are a lot more factors that can significantly affect stock's future value. So that's where the regression starts to fall short. Regressions are actually good at analyzing the individual data points, but they struggle to understand how these data points connect over time. So this means the regression algorithms find it difficult to remember the multiple events that occurred in the past. So that's why we turn to a special kind of model called LSTM, long short-term memory. LSTMs are like regression models with built-in memory. They can remember the past events and use that information to make the better predictions about the future. So it's like giving our model a pen and paper to track all the ups and downs of the stock market. So it learns from the past data and recognizes the patterns over time. So the regression might give us the decent estimate of the price, but the LSTMs are the real experts in navigating the complex world of stock market because they are specifically designed to handle the complex time series data. You see, the stock market data is the time series data. Okay, so the LSTMs are specifically designed to handle such complex time series data. That's what makes them the perfect choice for our stock prediction portal. So you remember, regression is a tool that we can use for predicting the numerical values, like for predicting the person height or the weather or even the house prices, right? But even though stock prices are also a numerical value, regression is not the best fit for this specific task. Why? Because the stock data is a different thing. So it is complex and it is ever changing and it is also tied to time. We call this type of data a time series data. So to handle such complex problems, we often use neural networks. Neural networks are a type of machine learning model inspired by the structure and function of the human brain. Before we go further, let's clear up some terminology. You might have heard of both machine learning and deep learning. So think of this machine learning as a collection of tools or algorithms designed for different tasks. So we use machine learning algorithms to solve simpler tasks, as we discussed earlier in this section, that includes predicting the weather, spam email classification, etc. But when we have more complex tasks like image recognition or natural language processing or sentiment analysis, we usually turn to deep learning. What is deep learning now? Well, deep learning is a subset of machine learning that uses more complex algorithms like neural networks. So machine learning algorithms are used for solving the less complex tasks, while deep learning is used to solve more complex problems. In deep learning, a neural network is a model that mimics the human brain to recognize patterns and make predictions based on the data that we feed them. Let's have a closer look at this neural network. As you can see, the neural networks are made up of interconnected nodes. We call it neurons. They are organized in layers. These neurons work together to process and analyze information, which means the data that you feed into this network will travel through these neurons and processes the information. That's how our brain works. Just like how we learn from experiences, neural networks learn by adjusting the strength of the connections between the neurons based on the data that they see. The more data they are exposed to, the better they become at making accurate predictions. There are typically three types of layers in the neural network: input layer, hidden layers, and output layers. Well, input layer, this is where we feed the data to the neural network. Then we have hidden layers. Once our network has the data, the hidden layers processes and analyzes the data by extracting features and patterns. So think of this process, like a factory where raw materials are transformed into the finished product, right? So those main things happen in these hidden layers. And then we have output layers. Okay, so it's like a final layer where the network produces its final result, like prediction or classification. Notice there can be multiple hidden layers. The more hidden layers a neural network has, the deeper it is. We call this type of networks a deep neural network. Before I conclude this video, I just want to give you an example of how neural network work to predict the future. You have seen the clouds in the sky, right? The moment you look at those clouds, your brain's neurons are activated and you might predict that it's going to rain now. So what's happening in your brain? How are you able to make this prediction? Well, you're essentially giving your brain the input. the image of the clouds. This is similar to the input layer of a neural network where we feed the data into the model. You are actually giving the picture of the cloud to your brain, right? It's a process of giving the input. Now this visual input of the clouds traveled through your brain's neurons, okay, which starts processing the information. So this process is equivalent to the hidden layers in neural network. These hidden layers perform complex calculations on the input data. They try to extract meaningful patterns and relationships. In this clouds example, your brain's neurons are recalling and comparing the current cloud formation with the similar clouds that you have seen in the past. So based on these calculations and comparisons, your brain comes to a conclusion. It predicts that the current clouds are likely to produce rain. This final prediction is similar to the output layer of a neural network, where the final results of the model is produced. Of course, our brains are far more complex and sophisticated than any artificial neural network so far, but the basic principles of how they process information and make predictions are significantly similar. Now that we have learned that our stock prediction problem falls under the complex task category, we need a specialized tool from the deep learning toolkit, not from the traditional machine learning toolkit. That's why we are exploring the neural networks, right? So let's have a look at what the deep learning is offering to us. Neural networks are the foundational building blocks of deep learning. There are different types of neural networks specialized for different kinds of problems. We mainly have feed-forward neural networks, recurrent neural networks, convolutional neural networks, and other NN architectures. So feed-forward neural networks are the basic types of neural network where the information moves in one direction. It only moves forward. So which means the data enters through our input layer and gets processed in the hidden layers and then exits as a prediction through the output layer. So it is very simple. The data moves in a forward direction. So FNNs are great for tasks where the order of the data does not matter. For example, recognizing the images. You scan the image from top to bottom or bottom to top. Doesn't matter. The content remains the same, right? So that's why the order of the data does not matter in feed-forward neural networks. But what if the order of the data does matter? For example, the stock market data. They are sequential time series data. So each piece of data represents an event that occurred at a specific point in time. So the order of these events are very important for understanding the stock market's behavior and making the predictions about the future direction. This is where the recurrent neural network comes in. RNNs are a type of neural network designed to process sequential data where the order of the information or the data matters. Essentially, in the stock market data, we have daily high, low, closing price, or the trading volume and the earning reports, etc. Right? The order of these data with a specific timestamp matters. And the recurrent neural network has the built-in memory. They can remember the previous data while processing the current input. So I've written short-term memory here. Don't worry, I'll tell you why in a moment. And then we have CNNs, convolutional neural network. The convolutional neural network is mostly used to analyze visual data like images and videos. So for stock prediction, the price of a stock mostly depends on the past prices and past events. So can we use feed-forward neural networks to predict the stock prices? No, because in FNNs, the data only moves forward. It doesn't look back at the previous data, right? Because it doesn't have any memory. And of course, CNNs can only be used for analyzing the images and videos. So our problem statement is completely different. We cannot use CNNs here. Now we are interested in RNNs, a recurrent neural network. It has the built-in memory and it can look back at the previous data in the neuron and predict the next output. So this is what we are interested in because the price of a stock mostly depends on the past prices or the past trends. So RNNs are a special type of neural network designed specifically to handle sequential data where the order of the data matters. Okay, like stock prices. It's a sequential time series data. The most powerful thing about RNN is they have built-in memory. Unlike FNNs, which treat each input independently, RNNs have internal loops that allows to remember and utilize the information from past inputs when processing the current input. Okay. Let's say an RNN is reading a sentence. I am born in France, so I can talk dash. So as you know, we have layers in the neural network: input layer, hidden layers, and output layer. So the input starts going to the network word by word. From the input layer, the first word that goes to the network is I. So when RNN sees I, it understands that someone is talking about themselves. The next word that goes to the input is am. So when it sees the am, it understands that it's in the present tense. And next word is born. Now it will know the person is talking about their birth. You see, when it gets the input born, it also remembers I and am, which are the previous inputs, right? So similarly, the next word is in. Now it will expect a place. And then the next word is France. I am born in France. Now it knows the person who is talking about themselves is born in France, right? So next word is so. Now it will know there is a conclusion coming. Now the next word is I again. The RNN will think the person is still talking about themselves. Okay. And the next word is can. So it knows they are able to do something. And then we have talk, right? So I can talk, right? It knows he can talk something. And next we want our RNN to predict the next word. So at this point, the RNN has understood the context. Since they were born in France, the RNN is likely to guess the next word, French. I am born in France, so I can talk French. So it's like a human being following a conversation. The RNN remembers what is heard before to understand what's being said now. That's how it makes smart guesses about what comes next. You see, this is my course content from a previous course. It's a pretty comprehensive course with 37 hours of content, 34 sections, and 248 lessons. Imagine you are a student taking this course. As you progress through the lessons one by one, you will likely remember what you have learned in the previous lesson or the previous section. That's because your brain has a memory that helps you connect new information to what you have learned previously. So this is similar to how an RNN works. It processes information step by remembering the previous inputs to understand the current one. However, as you get further into the course, you might start to forget some of the concepts you have learned in the earlier lessons, right? So for example, you are right now in the section 12, right? So you will likely remember what you have learned in section 10 and section 11, but you might forget some, few of the things that you have learned in earlier sections, which is in section 2 or 3, right? That's because your memory has its limitation and it's hard to remember every detail for a long time. So RNNs also face similar challenge. As they process longer and longer sequences of data, their memory can become overloaded and they might lose track of important information from the earlier inputs. Okay, so this is where LSTM comes in. So LSTM stands for long short-term memory networks. Imagine LSTMs are a student with an incredible talent. They can remember each and every word that he learned in this whole course, right? So because he has that super powerful memory. So LSTMs are also like this extraordinary student. They can remember the data and events from the very long time. So the basic RNN, or we also call it vanilla RNNs, they have the short-term memory. So LSTMs are like RNNs with super powerful memory capabilities. Okay, so they can still process information step by step, but they also have this extra long-time memory that helps them understand how different concepts relate to each other. So in the context of stock price prediction, LSTMs can remember the important events in the market, even from the long time ago. They learn how these past events affected the prices, like when and what time the prices went down, what was the volume, and when it came back up, and every useful information. and patterns. And then it uses that knowledge to predict what might happen next. So this is the high level overview of RNNs and LSTMs. So because of the long-term memory capabilities, we are going to use LSTMs to predict the future stock prices. Alright, that's how I went from basic machine learning all the way to choosing LSTMs for stock price prediction. You see, it wasn't just about picking the fancy algorithm. It was about understanding the problem statement. And I know stock price prediction isn't a simple game. In fact, predicting the exact price for tomorrow, that's next to impossible, at least in 2025, because of how unpredictable market sentiments are. But this video wasn't about predicting the future perfectly. It was about helping you understand how to choose the right machine learning model for any use cases. If you found this video helpful, drop a comment below. What ML model are you working with right now? And if you're interested in learning more practical machine learning content, make sure to subscribe so you don't miss out. Thanks for watching, and I'll see you in the next one.